now that we've talked a little bit about the derivative and how to calculate some of them, we'll talk about the relationship between a function and its derivative. While we know that the derivative gives us the slope of the tangent line, it actually tells us a little bit more than that. If our derivative is positive or negative, we can actually tell a lot about our function. One of the things we can say is if our derivative is positive on some interval a to b, then our original function is actually increasing on that interval. In addition, if our derivative is negative on an interval a to b, then our function is decreasing on that interval. So we'll look at some graphs and see how this works graphically, and then we'll actually do some examples finding it. The important thing to note here is I specifically pointed out greater than 0 and less than 0, but not what happens when it's equal to 0. And as we do our examples, we'll discuss exactly what happens whenever your derivative is equal to 0. Here I have the graphs of sine and cosine, and we know that the derivative of sine is cosine. So we've discussed that d dx of sine x is equal to cosine x. So let's look at what this means. This is 0, here's pi, and this point here is pi over 2. You can see that from 0 to pi, our derivative function cosine is positive because it's above the x-axis, and our sine function is actually increasing as we move left to right. Between pi over 2 and 3 pi over 2, cosine is negative because it's below the x-axis, and you can see that on that time our sine function is decreasing. From 3 pi over 2 to 2 pi, our cosine is once again above the x-axis, so it's positive, and once again our sine function is moving up and to the right, so it is increasing. So we can see this relationship here. Let's look at one more graph and then we'll discuss how to actually do examples of this to find increasing and decreasing intervals. Here I have a quadratic function and a line, which is a linear function, and the derivative of a quadratic is a linear, since we would bring the exponent of 2 out front and then subtract 1 from the exponent. That would give us an exponent of now 1. So let's see if we can notice our increasing and decreasing. Our quadratic is decreasing up until this point, and you'll notice our function, our line, is below the x-axis up to that point. So it's negative when our function's decreasing. When our quadratic is increasing, moving up and to the right, our line is now above the x-axis, so it is now positive. So that shows us exactly what we're talking about whenever we say this, some graphical pictures to explain my increasing and decreasing. So let's talk about how to actually find this given a function. So we talked about what happens when the derivative is positive, our function's increasing. If the derivative is negative, our function's decreasing. Well, if we have a point x0 where the derivative is actually equal to 0 or doesn't exist, then we call this a critical point. And essentially what we're going to have to do is take our derivative and figure out when it's equal to 0 and go from there, see what we can figure out. So let's look at some examples. Here I have the example x cubed, and I want to know when it's increasing and decreasing. And chances are you probably do know what the graph of this looks like, but we're going to do this using calculus. The idea is we want to take the derivative. We would bring the 3 down and subtract 1 from the exponent. And then we figure out when this is equal to 0. And you can solve this equation, but you should be able to figure out that the only time this is 0 is if x is equal to 0. So this is our critical point. We'll now draw a line. Here's 0. Any numbers to the right of 0, like 1, if I stick them into the derivative, I would get 3 times 1 squared, which is positive. If I stick in a number to the left, like -1, I would have 3 times -1 squared, which is still positive. So my derivative is always positive, so this function is always increasing. And we do know what the graph looks like, so we should be able to figure that out fairly well without calculus, but now we do see it. Here we have another function, and I specifically want to know if this is increasing or decreasing around the point x equal to -2. We're going to start by taking the derivative, bring the exponent down and subtract 1. The derivative of 4x is 4, and the derivative of a constant is 0. And then we're now going to evaluate this at -2. So I have 2 times -2 plus 4, which is -4 plus 4, which is 0. So this is our critical point. What happens around it? Well, if I pick a number to the right, 0 is a good one, and look at my derivative. 2 times 0 plus 4 is going to be a positive number. If I look at a number to the left, like -3, 2 times -3 plus 4 is going to be a negative number. So we can actually see that from -3 all the way, from negative infinity, all the numbers smaller than it, to -2 is decreasing. And from -2 all the way up to infinity is increasing. So we are able to figure out exactly where something's increasing and decreasing without actually having to graph it.